Thank you very much. Good afternoon, everybody. It is really my great pleasure and honor to have the opportunity to speak at this high-profile, beautiful meeting. And I want to thank the organizers very much for giving me the opportunity to showcase some of our results done here locally on early black holes with JWST. And here focusing mainly on the integral field spectrograph. We've already heard from Andy Bunker earlier this morning some of the JADES results, which uses the multi-shutter array, and these are complementary approaches of the NIRSpec-GTO team to try and understand and advance our knowledge of early galaxies with JWST. So we've had this morning very nice highlighting talks illustrating how we learned in the past decades an enormous amount about the general properties of galaxies and how they evolve over cosmic time in the past decades. And I want to use this plot here just to highlight how JWST is really pushing our boundaries of spatially resolved information into the first billion years, into this epoch where we think that the first galaxies, the first stars, and also the first massive black holes have been forming. And to show you that this is not just some sketch that I made under this plot, but it's actually a fact, I'm showing here a plot by Jan Scholz, who's a postdoc here in Cambridge, illustrating how previously, okay, it's not working. Before JWST, what we've known about AGN here in this framework of bolometric luminosity as a function of redshift was really restricted to this upper area, the gray shading and the small crosses, while now with JWST, which are all of these results that you see down here, we are really pushing to much lower luminosity, so we're probing a population of lower luminosity AGN, and also we are going to higher redshift, and I want to talk in a bit more detail about a few of these objects. So first here, I want to show our most beautiful object that we discovered early on in the IFS survey, the galaxy 3073 at just 1 billion years after the Big Bang. And what you can see in this beautiful spectrum, here the flux is in log scale to highlight these features, is that we have these very nice broad lines in the hydrogen and helium lines. We actually detect a wide range of helium-1 and also helium-2 lines, other high ionization lines such as argon-4 and even corona lines. And we also have a prism coverage of these objects extending to shorter wavelengths in terrestrial UV. And Shihan Yi, who is a postdoc here in Cambridge as well, has wrote a very nice paper highlighting, for instance, in this object, the high nitrogen abundance that Andy also mentioned in his talk earlier today. And so, of course, many, many people have been working now in the past 2 years with this JWST data across the world in discovering many of these low luminosity AGN. And with this spectrum, you can imagine that there's a plethora of physical properties of these objects that you can constrain, but I want to focus today on the black hole properties. And what we've been using with this data, and what generally has been used now in these past years, is the so-called single epoch virial calibrations. So these are calibrations that relate the luminosity and the line width of these broad lines, which is highlighted here in purple for this object, to a black hole mass. And so, of course, this comes with some uncertainty. There's a huge scatter already in these relations of about 0.3 to 0.4 dex. But I want to highlight some other caveats that have been noted recently in the literature that are related to this. So one thing is that there was a measurement earlier this year by the Gravity collaboration doing a first dynamical black hole mass measurement just about 3 billion years after the Big Bang. And what they found is that comparing this dynamical mass measurement to these single epoch calibrations, for instance, of the H-alpha line, suggests that these black hole masses might be slightly overestimated by up to a factor of 2, and for some other lines in local calibrations, this can get a little bit worse. Another thing that I want to point out, work that has been done here by Roberto Maiolino, is a fact that I didn't highlight before, but this object that we're seeing here is actually in one of the deepest X-ray fields that we have available, but we do not detect any X-ray emission. And this has been noted for many of these early AGN that have now been discovered with JWST. And one possible explanation for this X-ray weakness, we've discussed this, of course, with Andy Fabian here and others, is that there is a much higher covering factor of the broadline region around the black hole, which might absorb some of these X-rays. And so, of course, if this broadline structure around the black hole is changing, this would also indicate that these local calibrations cannot be applied. So there could be another factor of maybe up to 3 or so that these masses can be overestimated. And there have been several papers, of course, by other groups in the world as well, highlighting the X-ray weakness and also looking at these potentially high, very high nuclear densities, also finding absorption in the broadline region and also by students here, Ignaz Church-Schwalis, for instance, very interesting work that has been led in this direction. Now, what I want to convey to you is that even with these systematic uncertainties and unknowns that we have, is that when we look at a population of these black holes in the summary plot here by Ignaz, who is a PhD student here, compared to the local relation in black hole mass versus stellar mass, is that even if we correct down maybe by even 1 order of magnitude, most of these black holes at a fixed stellar mass are much more massive than the black holes that we find in local galaxies. And this is, of course, very interesting and needs to be understood. And of course, we've already seen this beautiful diagram by Martin, almost this diagram almost as old as the IOA, discovering and exploring different ways of how early black holes can form. And in this context, I want to tell you a little bit more about some of the research that we have been done here, which is not the main formation channel and main growth channel of these black holes, but it's very exciting for us in exploring further, also in connection to future missions such as LISA, which is black holes that might be emerging in the future. And so here I just want to highlight some work done by Michele Perna, who is a fellow in Madrid, on leveraging the field of view that we have with the integral field spectrograph. So this is 3 by 3 arc seconds, and this means we can not only probe the properties of these black holes and of the galaxies, but we can of course also explore the surroundings. And what he found is that in our survey there is a surprisingly high fraction of dual AGN. This is looking at separations of 3 to 10s or a few tenths of kiloparsec, which seems to be actually higher than what has been predicted so far by simulations, although there's always some uncertainty, of course, in the selection function in making these comparisons. So this is at somewhat larger separations, as you can see in these example images. Now going to smaller scales, here showing some data from the JADE survey, work by Roberto, we saw that there are some broadline regions that have somewhat peculiar shapes. And this can be interpreted as actually having 2 black holes close to each other within this slit. So here you see the MSA slit. And of course, without having this additional spatial information of the integral field spectrograph, there are a number of uncertainties related to these measurements. And so we have been very excited to find in our IFS survey the example of this galaxy here at redshift 7.15, where you can see that offset from the main line emitter that you see here in blue and in this lighter blue color over here in the primer image of the source, we see a broadline region, so indication of an accreting black hole that is offset by about 600 parsecs in projection from this other cloud of gas. And you can see also here in the imaging this color gradient. And interestingly, is that when we analyze the spectrum, the main spectrum of this other line emitter, we see that there are some other indications that we actually have here a narrow line AGN. And this is shown in a diagnostic that has been recently developed by a visiting student here, Giovanni Mazzolari, in using the aurora line diagnostic, which was also mentioned earlier by Andy Bunker in the talk. And so we interpret this as an ongoing galaxy and potentially massive black hole merger. I didn't want to show this actually, but now I've included it since Christoph asked the question about this. So we've seen, and many other teams have actually seen this, that the BPD diagram is not longer effective in selecting low luminosity AGN. And so, of course, we've started to explore, and teams in the world have started to explore potential alternative diagnostics. And here, of course, we can learn a lot from the research that has been done in nearby galaxies and utilizing the UV diagnostic lines to identify AGN. This is work by Jan Scholz. Or, as I mentioned earlier, in using, for instance, the aurora line in relation to other line properties. And we're trying to push here the field to identify new diagnostics that can still be effective in these low metallicity systems. And this is also work that will develop much more, I'm sure, in the coming years. Now, before I come to the end, I want to highlight just more in general, really the power of the integral field spectrograph in helping us to understand the properties not only of the black holes, but also of the host galaxies that these black holes reside in. Because eventually, of course, we want to understand what is the relationship and how do these black holes and the galaxies grow and evolve together, seeing these differences of these overmassive black holes to the local universe and understanding the connection and the changes over cosmic time in this area. And so here I'm just highlighting two works from our IFS GTO survey, where you can see that we can not only constrain properties of the black holes through these broad lines and outflows, etc., but we can also really constrain the host galaxy, getting these beautiful rotation fields, giving us access to dynamical mass estimates, which might give us a much better handling actually on the black hole versus host galaxy properties. And this work that we're doing here with the survey and in the extension of the next years will hopefully shed some light on these individual objects, on this detailed connection between the black holes and the galaxies. Now I know that Andy would like to have a lot of the JWST time, and so he might not be happy, but I'm actually very happy that we were successful in securing a large program to do exactly these studies, to use the integrated field spectrograph. And we have here a large program where we study about 25 of these AGN that were discovered with broad lines, but only with the NIRSpec-MSA, so where we are lacking the spatial information. And we will target them with the integrated field spectrograph. So we want to characterize here this host properties, what I just mentioned, this additional information that might help us to constrain really the connection between the black holes and the host galaxies. Of course, we're interested in looking for more of these binary, potentially future merging black holes, look at feedback, and also at any possible contaminants, which we will then be able to do, for instance, by comparing this data that we already took or that other people already took with this new program in the future. And so with this, I think I'm out of time. I just want to leave my conclusions up here. So we are now pushing into a regime that was previously unexplored at higher redshifts and lower luminosities of these accreting black holes. There's a lot that still needs to be understood. For instance, these intriguing properties such as the X-ray weakness, absorption lines, absorption features in the Balmer lines, etc. And we and also others in total dedicated more than 200 hours with the NIRSpec-IFS, which is really a substantial investment from the community in understanding these projects, objects further. And finally, if this is a topic that interests you more, then I want to highlight we have a conference coming up here in Cambridge next year in September that we're dedicating to this topic. And so I encourage you to have a look out for this. Thank you very much.